G'day everyone, how are you going? Back here with some logistics equations. Now this is a topic that brings together a huge amount of things that you've been doing. So I wrote this one out before and I think I've actually made a mistake somewhere, so hopefully we can pick that up on the way through. But if we don't, I'm not worried about that. I'm worried about the skills in this logistics equation idea. So let me talk about logistics equations first. This blue curve here is an e to the x type of curve. It's an exponential growth. So you remember with those that the growth keeps getting greater and greater as we go along, right? Now you might think, well great, what's the problem with that? And in the lower realms of this, in the early stages, there's no issue with that. That's what generally happens. Now it's very topical at the moment, but coronavirus, right? In the early stages, this is what would have been happening in every single country. Okay, then they put different strategies in place and things like this, testing and isolation and all of that, and that would have had an effect. Now what generally happens is after a while, those strategies and things that have been put in place start to affect the growth rate of whatever it is, in this case a virus, and hopefully it starts leveling out at some sort of level. Okay, now that leveling out, the kind of flattening of the curve as you would have heard, is the idea that the mitigation strategies have limited the growth and therefore we get to some maximum point. Now in logistics equation we call that the carrying capacity of the land, or the carrying capacity. Now think about this in terms of away from coronavirus and animal. Let's introduce a new species of animal, maybe a dog or something like that, into an area, 50,000 square kilometres or whatever. Now that animal, maybe we only introduce a couple of breeding pairs, but they breed, they have puppies, they grow, the population grows to a point where they find their happy medium in the ecosystem there. Okay? There'll be other higher order predators, some lower order predators, and they find their happy medium. Okay? Now, what's going to happen is that land, based on the constraints they have, the size, the amount of food, the pecking order, all of those things, it'll allow growth initially, but then at some point that growth starts to slow and then level out at some maximum level based on the particular environment, whether that be the virus in a country, whether that be a new species in an area, whatever the case is. Now there's a huge amount of mathematics in here, but that's where the basic understanding comes from, is that exponential growth, eternal exponential growth is impossible. So somewhere it's got to level off, and that's where we get this logistics equation. Right, now I'm going to try and not make any mistakes as I make my copy from here, but if you spot something that I've done wrong, please tell me, because I'm pretty sure I have made a mistake somewhere. Usually they're given in this sort of idea, okay? Now if we didn't have this part here, you would see that go, what, I've seen that before, I can write that as e to the kt, right? And that would be our exponential part. But now that we've got this part as well, notice how it's minus and it's squared. So as time goes on, as the population gets bigger, this part is going to have a bigger effect, and because it's minus, that's why it's going to do this. It has minimal effect over here. But as we go on, it's going to have a bigger effect. Notice also the value here is very small compared to this one. And that makes sense that at low n values, population values, this is the dominant part. At high population values, because of the square, this starts to have a really serious effect on it. So you can kind of already see that so much is in this, and I haven't even started working anything out. Right, what are we going to do? Well, I'm going to put it into a couple of fractions. 9 over 20n minus 15 over 100. Oh, I think I've spotted a mistake here. 1, 2, 3. Oh geez, I've already spotted a mistake for myself. Maybe that's why it didn't work out for me. 15 over 1,000 because I'd moved it 1, 2, 3. I had 15 over 100. Maybe that's my mistake. Anyway, let's see how we go. Hopefully I can get through. So then from that's actually going to change all my numbers. Right. So we'll work it through. Here we go. So now what I want to do is I want to put that on a common denominator, and I'll choose 1,000 as my common denominator because I've already got that there. So this is going to be 15n squared, that's not a problem. 20 times 50 will get me to there. So 50 times 9 is 450, that's going to be 4,500. Right, so I've got that on a common denominator. We're looking okay there. What am I going to do next? Let me check. Right, let's take a common factor out of the top line. if we have common factor. Are we still on video? Yes, we are. Good. Top line, n outside of 4,500 minus 15n over 1,000. Did I miss something?
Are you sure it's 4,500 and not 450?
Let's check. I've got to multiply the bottom by 50. So yeah, you're right actually.
Yeah.
Thank you. Please do check my numbers as I go through. Clearly this is not really going to work for me here so well. Right, so I've got that part there. That's my dn dt, isn't it? Right? Okay, we've got that part. Now what I want to do, I want to split that up. So now what I want to look... actually, hang on, wait on. I want to split sides. Right, here we go. I'm going to leave the dn over there, and I'm going to take all of that over that left-hand side. So I'm actually going to get 1 over n brackets 450 minus 15n dn, and leave this guy over here for the moment, but bring the dt over to here. That'll be 1 over 1,000 dt. So I've split my n's and everything else over here, right? Now this here, I want to integrate that, but remember that's going to be real tough to integrate, isn't it? But we can use partial fractions and split that up. So let's try and split this up, shall we? Don't we then have, I'm just working with partial fractions, let me go in a different colour here. So, wouldn't I have that a over n plus b over 450 minus 15n has to equal, well when I do that it's got to equal this whole thing, doesn't it? 1 over that there. So multiply this, isn't it? That times that, so it's a lots of 450 minus 15n plus that there plus bn has to equal 1. Okay? Multiply this out, we've got 450a minus 15an, now we've got to be careful how we work these, plus bn equals 1. Now on this right hand side we've got no lots of n, do we? Right? So this part here must be all of this part here, mustn't it? Right? That's kind of splitting up your i's and your j's in vectors, or looking at which bits. This is kind of like the real component. This is kind of like the imaginary component. They're different things. So therefore a must equal, it's got to be 1 over 450 to get here. Okay? Now that we know that's going to be the case, can't we work this, which that has to equal effectively 0. So minus 15an, I'm going to move that guy over to the other side and call it minus bn. But if I get rid of the negatives as well, it tidies up a little bit. And then if I make a substitution of this 450 into there, right, when I get 15 times 1 over 450, I can get rid of the n's because they're on both sides. So 15 over 1 over 450 equals b. 15 and 445 is going to be 3 there. So b is going to be 1 over 30. Alright, so that's our separation of variables idea that we need here. Just be able to split this guy up. Right, let's put that in. So now we're going to have, reading here, a was 1 over 450. So I'm going to have 1 over 450 over n, we'll tidy this up in a minute, plus b, which was 1 over 30, 1 over 30 over 450 minus 15n dn. I'll get to the next bit in a minute. Am I still on screen there? Yes, let's turn you around a little bit. There we go. And then on the other side, I'm still going to have this guy. Right. So we've got that crazy little thing going on. Now, what could I do here? Well, I can tidy up a little bit here if I need to. Can tidy up a little bit here. Can you see that I could take out, what can I do? Oh, I did tidy that up, but it's not going to work so well because my numbers are different here. My numbers really were a little easier here in this part. I took a common factor out the front, but I don't think I can anymore with this. I'm just trying to think how I can tidy up.
Well, do you modify the fractions to one fraction?
These guys out front, yes, or I can flip them, but I don't actually want to because I'm just thinking where I go with this, you see.
Or you can just put the 1 over 30 times 450 times 15.
Right, hang on. Oh, let's leave it. I'll show you the next step. The next step is to integrate both sides, and I'll show you where I'm going to go with this, you see? Because forget about this guy at top. No, this will work fine. This will work fine. See this 1 over 450, right? See that as something out the front. Okay, so kind of take that one out the front of 1 over n. Can you see how that's kind of like a 1 over 450 out the front of 1 over n? And we're integrating 1 over n, that's ln of n, isn't it? Because the derivative would be on the top line and the bottom. So this actually becomes that guy right there. And in a similar way, this will be plus 1 over 30. This will tidy up for me now. ln of 450. Now this is where I've got to be careful, right? Because the derivative of this needs to be on that top line, doesn't it?
Yep.
Okay? The derivative of this is minus 15. So I would need a minus 15 here, and therefore I would need a minus 15 there. So that means this becomes a minus 450. Okay? Just see how I did that? I needed a minus 15 here, or from there. So I put it there, but then also put one on the bottom line, so I haven't changed it, have I? Same top and bottom, but I used that one when I was getting the integrated version of that, and I used that one and that one have come through to there. Okay? Now the right hand side's pretty easy really, because that's just t over 1000 plus c. Right? Integrating this would be t over 1000 plus c. Now, another tip of this plus c. Remember that I didn't put a plus c over here. I put it over here. I don't need it on both sides, right? Because they're going to cancel out anyway if I put them on both sides. Just throw it on the right hand side. Now, let's keep tidying up. See a 1 over 450 here and a 1 over 450 here. Let's get them out the front. 1 over 450. Now, brackets. ln of n minus ln of 450, this one. Isn't that ln of n over 450 minus 15n? Make sure you're happy with that. I brought the 1 over 450s out to the front. ln of n minus ln of this one means I put it on the bottom line.
Yeah.
Okay? Equals this guy over here. Now, the next step that I've got to do is then recognise I want to get rid of, well, this guy here, I'm going to throw him over to the other side. So 1 over 450 here, multiply by 450, multiply by 450. Can you see how this is now going to be 450t? Right? Now I can do a bit of tidying up over there if I need to. Now what I've got to see, oh gee, colours are going everywhere here. Now I've got to see that if I take e to the power of this thing, I'll cancel out the ln part, won't I? And I've got to do e to the power of all of that. So what I end up here is this all cancels out to n over 450 minus 15n. Okay, equals, now, watch this, I'll do a couple of tricks into one here. E to this whole thing, isn't that the same as saying e to this times e to this? Because if we've got e to the power of something where we're adding some stuff together, we can separate that into two different ones, can't we? So this is going to be e to the power of, well, let's do a tidy up on the numbers here. Cancel, cancel. 45 over 100, isn't that 9 over 20?
Yeah.
Yep. So e to the 9t over 20 times e to the c. Just check that you see that. Because we're multiplying here, if I wanted to put them together, I'd add on the top line. Right, we're kind of getting there, We've got more to do yet. So, this is looking pretty good at the moment. Now I'm going to say, let e to the c, that's kind of my constant on the end, isn't it? I'm going to let that equal a, right? Now you can let it equal whatever you like, but let it equal a, that's kind of my starting value, right? That's my population 0, my starting value. We did that back when we were doing these guys, we did that. Okay, that was a similar step. So now what I've got is n over 450 minus 15n equals a e to the 9t over 20. Right, we're kind of getting there, but we're not quite in the format that we need yet. We want to tidy this up a bit more. It's getting crazy. Right, hold on to that one. Now I'm going to need to rub a little bit out. So hopefully I can kind of fit the rest in here. I'm not sure that I will. Right, so where am I up to in my little notes here? Right, there we are. Nope, we're not there. We're not there. Where are we? Oh, here we are. Right. What did I do next? I needed to play around. Oh, that's right. I need to multiply some things out. So I'm going to multiply this bottom line up over to here. So can you see that I would end up with n equals 450 minus 15n lots of a e to the 9t over 20. Multiply that bottom line up over there. Now when I multiply this out, can you see how one of the terms that I get will have an n in it? The other one won't have any n's in it. When I multiply that out, I'm then going to take that term with an n in it and bring it over to this side. So follow with me here. I'll move the screen over in a minute. I think I'll have n plus, because this 15n multiplied by that, but then moved over to this side will be plus 15n a e to the 9 over 9t over 20 equals, what I'll have 450 lots of that. 450 a e to the 9t over 20. Right, now let's get you back over this way a little bit. There we go. Okay, I think you can see. Perfect. Right, I'll try and stay out of the way. Now we've got that from what we had down there. Now what we've got to do is take a common factor of n out of here. Right, common factor of n, brackets, 1 plus 15 a e to the 9t over 20 equals that same thing there. Now, if I divide this whole thing over to that side, won't I get n equals 450 a e to the 9t over 20 over 1 plus 15 a e to the 9t over 20. Right, we're getting close. Now, in the book, this question, it says something about the population. When monitoring commenced, 500,000 people had the device. Okay, they're talking about a technology device. Now, 500,000, they're saying, i.e., n equals 0.5. 0.5 because it's in millions. So when n is 0.5, t is 0. Now, this I'm going to run out of room here, and I don't want to, but I will know n. I'll substitute that n equals 0.5 when t equals 0. So those things underlined, I will know. So I could then solve this to find out a, okay? And then I could put all that together with a rather than a variable. I will be able to solve for a and have an equation for n, the population, when all I got started with was the differential equation, or the rate of growth. So from here, what have I done? Let's do a quick recap. From here, I played around here. I got it into a step where I can put it together. Okay, same common denominator. I then said, well, you know what? If I split things up, move the n's over one side and the numbers over the other, I end up here. I'm then going to, later step I'm going to integrate, but I'm then going to use partial fractions. I better play around in here to get my partial fractions. I then said, well, let's write this part again, but I'm now going to integrate. If I'm going to integrate, I've got to make sure I have the derivative on top of the original. So I'll move the 450 out front. Here I had to do a little bit of a play around to be able to get here. I then took the 1 over 450 out front. That left me with a negative. So I could put these natural logs together and divide. Over here I had to integrate. So I put a plus c on there. I then said, you know what, get this 450 over to here. That allowed me to do e to the power of to get rid of the ln. That left me with just that. E to the power of this whole thing is the same as e to the power of the first times e to the power of the second. I let e to the c equal a to keep it easy. I was able to rewrite a little bit here, tidy up, multiply a few things out. Then, back over here, I then took that up over here by moving a few things around, common n out the front, which is what I want. And then that part I could divide over the other side, end up here. And then the book gives you an idea that n equals 0.5 when t equals 0. So then I can find a, and then that equation would be ready to use. That's a lot. I hope this has kind of helped. There's a lot of skills in here, okay? If I have made a mistake on the numbers somewhere, and I actually don't think I have, if I have, I apologise, but it's not about the numbers, it's about understanding the skills on the way through, and all this stuff you've done. Rearranging things, separating variables, partial fractions, natural logs, it's all here. This question is fantastic in terms of summarising so much that you've done. I hope this one helps. If I've really confused you, I apologise, but that's what it is. Enjoy. See you later.